There we go. We are live now. So thanks to everybody for joining us, the Programmability and Automation Meetup. With us is Michael DeHaan. He's going to talk about Jet and kind of what he's been working on and bringing to the community. So with that, I'll turn it over to you, Michael. And for everybody else, if you do have any questions throughout the process, we're going to save them to the end. So do that. But if you have anything you want to ask, you don't want to come off of mute, please drop them in the chat. We'll be watching there as well. So with that, off to you, Michael.
All right. Yeah. Thanks, everyone. Appreciate you all tuning in. If I go on mute or pause at random intervals, it's because I'm coughing and trying to not have that show up on the screen, but I'm going to try to talk the best I can. So, all right. So, Jet is a new configuration management tool. If anybody watching doesn't know who I am, I invented Ansible in 2012. Previously had some other open source systems management projects, and then I started in about 2006. A few other things along the way. But obviously Ansible got to be pretty popular, and is, by some people's estimates, used in like 60% of the Fortune 500 or something like that. So you may ask, why another configuration management system? And you may also say, well, didn't containers eat the world? Why do we even want another configuration management system? Obviously, the need to deploy clouds is still there. The need to maintain stateful data layers, databases, message buses, whatever, is still there. That's not going away. But there's a lot of people that kind of view the whole container thing as also too complicated and are still managing systems the way that they did in pre-container worlds. And I was actually surprised, but that is a very, very, very large segment. So there's still a lot of need for these kind of things. And I also kind of wanted to have a system that espoused some of the original virtues that I was trying to develop in Ansible in 2012, but take advantage of some of the new advances in technology that we've had since that time. I'm not going to show a live demo today, but Jet's remarkably fast, both in parallelism and on individual machines, and you'll see that if you try to install it. But also with having a language with a really, really good type system, I think Rust is absolutely fantastic in that regard. If you didn't know this was a Rust talk, this is a configuration management system written in Rust. So I think that'll be interesting for people that haven't seen it. But I also wanted to kind of look back at configuration management systems and some of the lessons learned from, what was it like developing Ansible? Where did we run into problems? So increasing the amount of error checking that exists in playbooks so people don't necessarily shoot themselves in the foot quite as often, to make it easier to ensure that modules are written correctly by having a little bit more of a framework for that. And also trying to see if we don't have to have any software installed on remote systems. So people would push Python before, but you would need Python. Most systems are going to have Python on it, but Jet operates just by running shell commands, which is theoretically pretty nice. So, and also a little bit faster. So I was thinking, excuse me just a second. So if you were to look at configuration management systems as if it were part of something like core utils, you think about user bin ls, user bin rm. These are not programs that surprise you, right? You never really go to look to see what's new in those programs. They're just always there and always reliable and always like exceptionally boring. And I want configuration management systems to be deployment systems, orchestration, whatever you want to call it, to be that boring where you don't have to like constantly be plugged into a community. If you write some automation content and you come back a decade later, that content should theoretically still work. It shouldn't be like, this is a completely new tool. So the approach here is to kind of take a little bit more of a hard engineering focus towards kind of a framework or a vertical, I guess, that has kind of evolved from people scripting things, right? So Rust being very, very type safe and very, very rigid. enforces that, but also things that we do in language design, like just making sure that we get the design right, so we're not going to have to change it, we're not going to have to deprecate anything. That's something that's important to a lot of people. And I don't want to see people being automation jockeys all day. I want automation to kind of enable you to go do other things, to research some other idea, to go write some code. And I said that back in 2012, if this thing becomes anyone's day job, I will have failed, right? And it certainly, some past projects did become people's day jobs. Like the whole YAML ops thing, and right, I want something to be boring and unexciting and predictable. So Jet is a more minimal system, but has a lot of similarities, which you'll see pretty soon. So basic diagram here. Basically, Jet is just SSHing into remote machines, and if you're familiar with Ansible, it's kind of the same, basic thing going on. The project is about 3 months old. I developed it basically kind of in private because I wanted to make sure that the first modules had a very good consistency to them before we turn them over to community contribution, because what happens is somebody always copies one of the existing things to make a new thing. So you want to make sure that everything is very on the rails, so to speak. So make sure the API is for modules is like perfect. So the aim is to release about once a month, but have a very, very stable language where content should not have to change from release to release. So if you write automation content, you're going to get some new features, you're going to get some bug fixes, if there were any bugs to be fixed. You might get some new parameters in some modules, but we're going to try really hard to not break anyone and not deprecate language features, and plan ahead for a very, very long length of time, which I think is sometimes very hard to do in a kind of like a revenue-driven environment. So this is definitely a community approach to building a project. So an example playbook. So again, this will make more sense if you've seen Ansible. If you haven't, what we're doing is we just have a simple YAML file that selects a certain amount of remote hosts to configure, and then we're applying a set of tasks or roles to them. So if you're familiar with Ansible, roles are just packaging of reusable automation content, right? So here we've got a role to configure Redis, and it takes some parameters. Tags are just a way to say, I want to run just part of this automation. And then we can also have some loose tasks. So if you go through the documentation, you'll get a better feel for what's there and what's not. I don't really have time to show that right now, but just kind of give you a basic overview in this next slide. Some differences you may see with Ansible is that we're using YAML tags for the modules. That's kind of related to how the serialization, the loading happens in Rust. The templates are from handlebars, not from Jinja, so it's a lot less flexible on purpose. So it kind of gives you a little bit less rope. And then the conditions are also from handlebars. We're trying to be a lot more strongly typed. So for instance, with mode, that has to be 100% a octal string. So if that doesn't start with 0 and little o, it will not like you, and it will not let that happen, and you'll get nice errors. So the whole system has kind of been designed around error checking and having minimal surprises, and how can we kind of enhance the clarity in various ways. And some of that is not presenting as many features, because if you present a lot of features, sometimes they get used, right? And we kind of have this problem with configuration management where people kind of program in YAML, right? And then they get content that's difficult to maintain or difficult to understand what it's going to do. So like, for instance, in Jet, we don't have dynamic includes of saying, go include this file based on this variable, right? That doesn't exist very, very intentionally. So if you read some content, you can tell, what it's trying to do. So when you run it, again, there's no, excuse me, there's no live demo today. You get some output that should look fairly familiar. You're just seeing for every host and every task what's happening. And then when you get to the end, There's because of the way that the module architecture has been designed, we have a very fine-grained knowledge of what happened to every resource. Was something created? Was it modified or removed? Or how many resources changed? So you kind of see that report at the end. That's kind of a result of the module architecture. And that makes sure that modules, when they come in as a contribution or whatever, it makes code review really easy, but it also makes sure that they're modeled in the correct way so that all the resources are declarative for the most part. So I really hate vendor sales pitches. I've been through a lot of them at conferences, and I don't want to persuade anyone that this is their favorite tool. So try it out. If you like it, great. If you don't, great. So I just kind of want to talk a little bit about Rust things, because show some of the internals, some of the design choices, and if you're wondering, like say you're doing a bunch of Go, am I interested in Rust? What do I think of it? I kind of just want to share some opinions, and this isn't even an endorsement. This is just kind of a here's what happened, right? So the type system I think in Rust is fantastic, right? So that has led to honestly a slower development time, but a knowledge that most of the time when something compiles in a really, really like freaky way, it tends to work the first time. And I've occasionally felt that when writing some like code in some other language, but never to this degree of frequency. So the type system is remarkable. Things like result and option and so on, and how it forces you to deal with error checking and dealing with results. A lot of the warnings are completely on another level from anything I've ever seen in any programming language. There may be some obscure ones that I'm not familiar with that might do a better job, but I was impressed. The compiler is a work of genius. Speed is remarkable. So we can, if we're processing like 1 million hosts in inventory, which is unrealistic because you're never going to configure that many. But say you have 1 million hosts in your cloud and you want to talk to just a subset or a microservice or a couple regions or something like that. We can process 1 million hosts in 4 seconds. So like I was blown away. That's unoptimized code. That's just Rust being completely to the metal. I have personal opinions about Go, but I have seen that it beats it on a lot of benchmarks. But Go would probably be fast enough, but we'd probably be looking at 12 seconds or something. I don't know. It doesn't really matter. There's great collection support in the language. So if you're trying to do things like lists and vectors and hash tables and hash sets, it kind of feels a little bit like Java, but it's well done. There's a really nice match statement for pattern matching that has really led to making sure that all possibilities and various conditions are handled, which I think increases code quality. There's some very nice locking and synchronization primitives. It's very easy to do things with smart pointers. The thread processing that we're getting out of a library called Rayon, which I'll show later, allows us to have like 100 threads at once, which is remarkably good. Serialization from YAML and JSON through this library that we're using called Surdy is absolutely fantastic. A little hard to use to get your brain around initially, but makes the whole language basically be defined by structures, where we didn't have to write a lot of code to load things and be very, do what I mean kind of sloppy kind of philosophy to try to figure out what the user wants. It will almost instantly tell you if you have a field missing and what the proper values are, and it's all built in. So I really appreciate that. And then you also still have that single binary, being able to build everything into one little program. So like I said, this wasn't meant to be a sales pitch. Rust has a big learning curve. The documentation tends to completely lack examples for any library you're looking at. So you're kind of dependent on Stack Overflow, which I've never contributed to, but thankfully there's a lot of content out there, and other people's code. There's occasionally some weird things you have to do to get around the borrow checker, where you have to add some weird, and not quite boilerplate, but some weird things that kind of make your code look ugly. But in general, it's pretty good. If you're looking for a fully object-oriented system, it doesn't have that. I was able to get everything I wanted done, but it was sometimes a little difficult to figure out. how to do some things, and there's a little bit more boilerplate than if the OO is what it should be. It takes a long time to get your head around the memory management and the synchronization, and you kind of learn by osmosis what the compiler wants. And then once you actually learn what the compiler wants, you'll eventually start coding that way, and you'll not really be able to explain why. It just works now. But your initial attempts will have not worked and will have produced lots and lots of errors until you kind of understand its way of thinking. But I have a hard time like actually equivocating what that way of thinking is. Standard library is pretty minimal, and there's a few features of the language that can, greatly reduce reliability or readability if you get into those async operations, which I'm mostly completely avoiding, except for this one library that wraps them very nicely for me. These things called lifetimes, which, if anybody's a fan of Stargate, it makes everything look like Google old language with like lots of apostrophes everywhere. And I've learned to avoid that. And then it has macros, which would appeal to all the Lisp people, but I find them very, very hard to write. So there are downsides, but I think in terms of what we needed to do for Jet, it's perfect. It does everything I need to do. I found the 3 libraries or so that I need to really get the heavy lifting done, and it's perfect for that. So it kind of does feel like a very expressive version of C, where you don't end up writing as many errors or something like that. But I don't know, it feels good. It kind of depends what libraries are out there for what, do you have the things that you need, right? I know people were telling me to go learn Rust like 4 years ago, and then the documentation never worked for anything. And I think now is the time where everything has stabilized, where it's a lot more feasible today. So just to talk about like what developing modules looks like. I'm showing you snippets of the apt module, which installs apt packages. And this will make more sense with the code checkout. So maybe if you're interested, you can download the code later, stop by our Discord channel. But basically, we're able to lay out every single parameter as a structure. So if you're familiar with structs from C or classes or whatever, the SERDI, which is our serialization framework, will automatically check that all the inputs were right straight up front without us having to write any of the code to parse those parameters. So that was a huge win. And the system separates out the idea of the task, which is what the user puts in the YAML file, from the action, which is essentially the evaluation of it. So you can see that the YAML allowed a string, but then but we actually coerced it to a Boolean later or something like that, right? So for everyone that's annoyed with YAML being able to type the word no and that being false, right, when it might be the country code for Norway, or the string no, or maybe a state abbreviation for some, something like that, or some country or whatever, we can actually just say true and false is all that's legal. And that's what we've done here to eliminate kind of polish off some of the rough edges of YAML. So once you lay out the structure for the module, and there's a development guide for this, we're basically describing the behavior of parameter by parameter. How do we take the user inputs and process them to get them into the format that we want to use? So like for update, if you leave off update, it's a Boolean option that defaults to false, right? So there's a little bit of boilerplate here that developers have to deal with, but it's great because in code review, I can see what was your default policy for all these modules. I don't have to read the code to understand what's going on. And it's all very, very consistent and fast and everything. So every function, the package modules have some common code. So everybody has to define the dispatch function, which is a state machine, part of the state machine. And this is what it looks like for the apt module for packages. So every module starts off with a query leg, which says, what is on the remote system? And I'll jump into this common query package function in just one moment. And do I need to make any changes? And then based on the action it decides, whether it decides something needs to be created or modified or removed or whatever, you implement those individual legs of the state machine. So it's not possible, if the system doesn't decide the resource is not present and needs to be created, it's not possible for it to create a resource that isn't there, right? So the entire module is kind of on guardrails. So this is an implementation of how query works for packages. So basically what we do is we say, if you ask to remove the package, we look and see if it needs to be removed. If we're updating the package, we check the remote version of the package that's available, and we compare it to the current version, and we say that there is a change that needs to be made in that version, and so on. So we're just building up the list of changes that needs to happen. And if no changes are made, we just say the resource is fine, and we return this is match, right? So this seems a little overwhelming, but it'll make more sense if you look at some of the other modules. But for instance, what we're doing on every one of these modules is we're just using the results of shell commands over SSH. So we're not relying on a remote agent, and we're not pushing any Python blobs or anything like that and running them. We're just basically running shell commands and parsing them. And because we're using libssh2 in Rust, and we can keep connections open and things like that, it's blindingly fast. So if we were using like a library that wrapped apt in like Python or Ruby or something, that would be pretty slow. But we're just using the shell, and it was really easy to implement these. So I launched this with like Yum and apt, and we had like Pacman and Homebrew and Zipper, and like it felt like a week or something like that. So some of the libraries that we're using underneath that are interesting. I mentioned Serde. Serde is very useful. So what you're seeing right now is the entire language spec for the program in essentially a screen full of code. So various keywords that we can attach to the plays and roles are just here with all the types that they allow. And when we load the file, it'll automatically tell us where the errors are. So here's an example. I wrote a little widget that drew the little arrow by the line in the middle. So the kind of the browser, but here we've added an invalid parameter to the shell module. And it says basically unknown field, invalid parameter, expected one of, and then it gives me the list of all the valid parameters. This just came from the parser. I didn't have to write any code for that. So that's pretty cool. So that kind of built-in robustness is like just from using Serde. So kind of example of like a lot of the Rust libraries that people write are written by some pretty smart people, and they do a really good job about being very correct. And I think a lot of that stems from like the nature of the type system and it being there to protect people from errors and things, and that kind of bleeds over into a lot of these libraries that you use. There's a library called Rayon. So when Ansible did its parallelization, because it was Python and we had issues with Python threading not really working on Linux at the time, it was using a library called multiprocessing, which would actually fork. So forking is, as you may know, very resource intensive. It copies all the existing process and takes some time. So we're able to use threads in Rust, and we're using it with a library called Rayon. So this code isn't the most beautiful thing, but if you look at the very first line in this file, you can see what we're doing is we have a list of hosts that we want to talk to, and instead of iterating over them, which would have been the function iter, Rayon is providing this thing called parallel iter, and then we're just walking over every single host. And then because we're using the map function, we have to trick it and tell it we're doing some calculations. So here we're just adding up 1 for the number of hosts in the list and returning the sum or whatever. So basically in this way, if we allocate 100 threads and we have 200 hosts, it's going to process 100 hosts and then do the next 100. And then we also have some features built in very similar to what existed in Ansible, to where we can say, fully process this many hosts at a time before moving on to the next set or whatever. But the thread pool can be easily 100 or 125 threads on a reasonable amount of machine. I don't know how high you can actually push it, because it's not forks, and you run it, the feeling is very tangible. So Rayon's a cool library. If you try to look at the async docs for Rust, I don't know if you've written async stuff in other languages, very quickly, all your code turns async and it completely transmogrifies your program. So I've tried very hard to only use that here and not let that happen. We're using libssh2 to talk to remote machines. So libSSH2 is a wrapper around SSH. So instead of calling SSH, we're able to use the library and keep connections completely open between operations. So with Ansible, we were using control persist in the past, which is basically saying, try to keep the connections open, but each time we're still spawning the SSH binary. Here we don't have to do that, so it's very, very fast. So the code isn't the simplest thing, but here is an example. It has built-in SFTP for file transfer. So this is the code that streams files. So there's buffered readers and writers around things that feels a little bit like Java, but it's a pretty cool library that does quite a bit. Doesn't do everything SSH can do. Like it didn't do SSH agent forwarding, so I had to show out the SSH in that particular case. Doesn't exactly read your SSH config files, but remarkably fast, and combined with Rayon and Rust together, that definitely adds up to a really, really fast program. I don't want to give anybody the idea that this is done for speed, right? This isn't really a speed project. This is a language stability, simplicity. How clear can we make content, right? Can you write content anyone in your team can understand, even if they don't know Jet, right? Does it keep working for years? Is it very obvious? Is it very easy to code review? So that's just kind of a refinement of past experience with the language. And then the speed is like the bonus. It's kind of the thing that gets everybody in the door, but you can really, really feel it. I merged in a user module today to add users. So we've got, I guess, like, I don't know, 20 modules, maybe 30. I don't know how much we have right now. Might be 20, might be 10, 15. I don't know. But just like adding users on all these different hosts and really, really fast, modifying them. It's like you snap your fingers and it's done, right? So that is about it. Very, very fast overview. If you want to know more, poke around the docs. Like I spent like weeks on docs, and Gitbook was really, really helpful for that. If anybody's trying to make docs for a new project, you don't have to know Markdown or anything like that, and you can just kind of click and make things really easily, and then it syncs to a Git repo. Anyway, the docs should be pretty helpful, but there's a Discord channel right now with like somewhere between 600 and 700 people on it. A lot of them are idle, so maybe it's 150, whatever. But that's a good way to ask questions to me. And there's also a Substack blog that's linked there as well. It's completely free, so I'm not charging for subscribers or anything. But like when new features come out or there's announcements, that's how we're doing announcements. So if you want to try things out and stay in the loop, all those links are on jetporch.com. There's currently like a DNS issue with Cloudflare, so make sure you put in the www or you might get some problems. That's kind of it for me in terms of like presentation wise. So like if you have questions, definitely happy to hear from you. I can't see the chat, so somebody's gonna have to read them to me, probably.
Yeah, so there's one in the chat from Val. The question is Rust is fast undoubtedly, but remote host configuration management is mostly dependent on network connections and executing underlying commands, shell, and Python. Does not it look like boilerplate? So speed of single jet binary shines only for local operations over the huge inventory?
So I'm not sure about the boilerplate question, but so the realism, right? So if you're configuring a large number of systems and you get to a package install step, right? The package manager is going to have to download a package and install it, and that's going to take some time. So in any of these configuration management tools, I think always individual speed is not super interesting. It's really about how efficient is the parallelism. So with Jet being able to say, here's like 120 threads, right, or 100 threads, whatever, and have those be really efficient. That's going to cover most cases, because most people are not configuring all their systems at once. Nobody wants to do that anymore, right? That used to kind of be the old way of like pushing out a monolith configuration, but now most people are kind of services based, and if you've got 200 nodes that look exactly the same in the region, you're doing something wrong, because you should be buying larger instances most likely. I have plans on, you can definitely run it locally. I have plans on making kind of a little bit of a framework around making that easier for, excuse me, checking out, content out of source control, or getting events from a bus, or, pulling things from object storage, kind of doing a push-pull or a pull-based model on top of things if you want to go there. But anyway, yeah, so I think the speed is there. It's noticeable. It's mostly from keeping connections open, and it seems like it is worth it, right? To a lot of people, I think like people can feel it. So try it out, see what you think. But yeah, realistically, yeah, you're going to be waiting on package managers and downloads, and that's still going to be there. So that, like I said, I think it's not a, don't look at it as a performance project so much as how do we make something that, like, how do you look at configuration management like it was part of core utils? How do you make something really stable? And how do you try to make it really, really accurate, right? And really handle, really focus on the error paths and the validation, and doing things the right way. Hopefully that answers the question. What's next? Thank you.
Rick, you've got a couple questions. You want to come off mute and ask those, or I can read them if not?
Yeah, no, that's cool. Yeah, no, thanks for taking the time for the talk. It's appreciated. So the first question was around, obviously you've still got like a kind of DSL there. You're still describing things in a YAML based format. Have you got any? Because I know with Ansible, you was always kind of shackled as soon as there's always issues as soon as you wanted to do a bit of looping of data or anything like that. It always became quite cumbersome because you had that kind of that kind of abstraction layer there. Have you got, is there any kind of anything that you've got that you're putting in to be able to help with those kind of issues that we've seen with Ansible before?
Yeah, well, so I mean, I think there's possibly two things. One is that massaging data is a challenge, right? And I think that in the past, not saying anything remotely bad about Ansible, what I saw in the past is a lot of times people would abuse like lookup plugins, and I forget the names of the loop plugins. I mean, I enabled that. I designed a lot of that. Then a lot of it changed after I left, where I didn't recognize how it works today, right? So I left Ansible in January 2015. So I kind of want to develop a more minimal system in many ways, right? So my view is automation should be like a grocery list for the most part. So if it is the case that you've got some weird data, we can load data from files with the -e, like the extra vars parameter in Jet. It's just like the one in Ansible, things like that. Vars files still exists, right? Maybe you pre-process that and you get it into the right shape, and then you just use the with operation. There's a with items structure in Jet, and you just feed it to that. And we expect that you massage some of your data out of band, right? Maybe that's the way to go. I don't want to create a lot of ways where you're looking at the language and you don't know exactly what it's going to do, or you have to rely on templating to put some stuff together. So I think it's an interesting balance between capability and giving someone too much rope, right? And it's kind of a weird thing, right? It's like, if I give too many features out, some of the content is going to be net negative the way that it gets used, because it's like too appealing and then it gets overused. So trying to make content that works for an entire organization requires some simplifications, and that's sometimes difficult, right? So you look at like why I don't like Go, right? Or why I don't like Java. I think like Dave Thomas had the quote about Java being the blunt safety scissors of programming languages, right? So they don't give you the chainsaw, and I want the chainsaw, but if everybody had a chainsaw, then the content gets complicated and devolves, right? Or it becomes hard to maintain. So it's kind of like when somebody has trouble doing something, we kind of ask, what can we do to make this like easier? How would we try to make this more idiomatic? And there haven't been a lot of those problems so far, because there is the ability to loop over basic things. but I don't want to be in a situation where we've provided some construct and we keep changing it and we keep breaking people like, oh no, we want to do it this way, right? So if there is a bunch of weird data, like I know that was popular in the networking community, I don't want to solve networking at all. Like that's not my field. I don't have the domain experience. I think processing some of the more complicated stuff out of band to get it in the right format might be the right way to go.
Yeah, no, that's cool. I get it. It's quite difficult. Yeah, problem to solve, like a lot of the points that you said. So that's cool. And so kind of that dovetails into my next question quickly, which was like, have you got any? Is there going to be like any hooks for? It's kind of bad term for it, but any hooks to be able to allow people to write modules or things, just but not in Rust. So
Yeah.
you know, if you want to kind of do something, write it in Python or something.
Yeah, absolutely. So I have this external modules plan. I think it's on the web page, and the idea is just basically push a script that takes JSON and push the JSON parameters for it, and then run it with that as standard input, get JSON back out, right? So any sort of scripting language that can take JSON in and spit JSON out will be possible. I may possibly provide ways to do that as mostly as a, like, it would get pushed to the remote node and we'd run it. That's really how Ansible worked back in the earliest days. But like all the core modules that we ship with, we want those to be in Rust because the type system makes them really, really high quality, and I can just compile them and I know that it works, right? So there's this freedom degree factor that I don't have with Python code. So where I see the other stuff happening is when people have like in-house APIs they want to talk to, or if like maybe they want to talk to a cloud API or something like that. Those would be good fits, and then we kind of like link to some of the better ones on the webpage maybe. But just kind of trying to get most everything back in Rust, because I think it's worth it, right? Just to know that the error checking and everything is there, and that those modules don't succumb to bit rot, like if you have too many of them or something like that. But we're also trying to keep that number of modules kind of small. But I think that leaves the door open to people. So yeah, that should be done probably within like less than a month or so. I want to get that out for the next release.
Okay, cool. All right, thanks.
Yep, welcome.
There's another question in the chat from Hunter who asks, can you go into more detail about the managing secrets page on the Git book?
Yes. So that's going to change just a tiny bit. So what we decided to do was support every secret tool possible rather than ever building our own like crypto implementation or anything. So like, I recognize I'm not smart enough to do my own crypto, so we're not going to build something like Ansible Vault, which is great. I thought that was a port of the idea from Chef Databags and had some good ideas in it. But in this case, what we're going to do is we're going to load variables from the environment. So, for instance, like obviously it's not really the most enterprisey solution, but it's one example. Like 1Password has a tool called OP Run, where it can output secrets from one program into another, make sure those secrets are redacted in the output of the program it calls. And it's really clever of a way to like essentially pipe secrets between programs. There are tools that are pluggable that support that. Now I'm coughing, now the presentation's about over. Excuse me. There are tools that provide like abstractions that can talk to, you know, like HashiCorp's Vault or whatever, that can also spit things into the environment. So that's just a good way for us to be able to plug into everything. The current docs say that those are only going to be available as templates, but I'm going to be reversing that really soon to where modules can take those as parameters as well. Just because those module calls don't show up in shell history, and the tools that support redaction of those values, which could be humorous. Like if your password is like 1234 and you redact every single instance of 1234, you could like make like the whole output completely blacked out. But this is what support redaction. You don't have to worry about it getting into build logs either. And then that was the main kind of concern that a lot of people had with some prior tools, is it was too easy to leak secrets into certain places. So it's just about supporting as many tools as possible without making a preference decision, which is the same thing we're kind of going to do with the agent strategy for supporting pulling from object stores or responding to events, is not make a preference decision that would limit the number of users that could use that feature because they weren't using that particular thing, but also still make it easy for you to wire up to like whatever you had. And if that kind of answers the question. Hopefully. All right, if you have anything else, feel free to ask. You can also, I don't know if we're set up to asking them audibly, but that's good as well.
Yeah, that's everything in the chat for anybody that's on the call. If you have anything to ask, just go off mute. We're ready and open for that. And then if we don't have a lot of questions, we can wrap it up and give everybody about 15 minutes back and go from there as well.
All right, yeah, sounds good, everyone. Again, like www.jetporch.com. There's links to the chat. Feel free to join the chat, ask questions later if you have them. And then the blog is pretty good as well, or a lot of it's older stuff as it was getting developed, but you may want to sign up for the Substack there. Thank you very much.
Yeah, thanks, Michael. Thanks everybody that's joined. Yeah, I'll get the slides from Michael. We'll get those posted on the community page with the recording as well, and have links to everything, so that if anybody who's watching this didn't attend live, we'll get you to the right contact information and the right pages to view all the content. So with that, thank you everybody.
Hey, Nick, do you want to plug the upcoming sessions that you've got lined up?
Yeah, there is. We've got a couple more meetups scheduled. The next one will be on the 29th. So on the 29th, the team from System Init is going to talk about, or their talk is titled "It's Time to Rebuild DevOps." So they're going to talk about their new platform and their tools and what they're focusing on there. We're going to take a break for the month of December, and then we will be back in January on January 18th with Ben Novak from F5, and he is going to talk about what. So Ben is responsible for the F5 Visual Studio Code plugins, and he is going to talk about how they work, what they do, and a little bit under the covers on what it takes to actually write an extension for VS Code. So a couple of good talks leading up to this as well. Thanks again to Michael for taking time out of his schedule to present with us today, and thanks to all of you for joining us, and we'll see you again at the end of the month.
Thanks, Michael. Thanks, Nick.
Have a great day.